We know that blood flow is really important throughout the body, and a really interesting study just found that taking 20 grams of creatine for just 5 days will actually improve microcirculation and blood flow after a high carbohydrate or high fat test meal. Now, this is really important in my opinion because we know reduced blood flow can increase your risk for having a blood clot and is also an independent risk factor for cardiovascular disease, sudden cardiac death, and poor outcomes. So let's dive into the study that was published in the European Journal of Physiology. The title of this article is Creatine Monohydrate Supplementation and a Nitric Oxide Synthase Inhibitor Impacts Skeletal Muscle Microvascular Blood Flow, a pilot study. Now, there's a few limitations. There wasn't a control group. There was just 5 participants. They were taking 20 grams of creatine monohydrate in 2 divided doses throughout the day, 10 grams in the morning, 10 grams in the evening time. But as you will soon see from these images that are quite fascinating, just taking creatine for 5 days, like a standard loading dose of creatine, 20 grams a day for 5 days, improved microcirculation and blood flow in skeletal muscle and also reduce some of the oxidative stress that is linked with poor circulation and poor blood flow. Now, this is really important for diabetics and insulin-resistant individuals because we know that peripheral vascular disease is a major predisposing factor for having amputations and limb issues and so forth. So, and also I think just in general, like women who have cold hands and feet or people who have cold intolerance, I don't know, I think creatine could be one tool for that. And it could mechanistically function by increasing cellular energy production within the smooth muscle cells of the arterial system in the peripheral appendages, such as the feet and hands and so on. So the authors go on to say that impaired blood flow and elevated reactive oxygen species concentrations generated primarily from ADPH oxidase indicate a risk for cardiovascular disease. Creatine monohydrate may reduce cardiovascular disease risk by lowering reactive oxygen species concentration and increasing skeletal muscle microvascular blood flow. So essentially they go into the materials and methods and talk about how there's different reactive oxygen species within the microcirculatory system that are problematic and can reduce blood flow and prevent nitric oxide from dilating the arterial system and so forth. They talk about some other studies that we'll get into momentarily that indicate that creatine could be helpful in this context. But I think it's important for us to all recognize that when we have either a really high carbohydrate meal or a high fat meal, what can happen in the post-meal window is there can be impaired blood flow to your appendages, in particular in the legs and in the arms and the microvascular system in general. And so they had subjects either have a high fat meal or a high carb meal, which is well known to impair nitric oxide synthase. And what they found is comparing the pre-study period where there was no creatine being administered versus just 5 days of a high dose creatine, there were significant improvements in the blood flow and a reduction concurrently in the free radical species known as reactive oxygen species or hydrogen peroxide and beyond. So I think it's important that we reframe creatine from this ergogenic aid that will improve muscular strength and endurance to something that generally improves cellular energy functioning and possibly mitochondrial function. So I think that's really important. There's some great charts here. This is the amount of hydrogen peroxide in the vessels. As you can see here, there are demonstrable differences between the pre and post creatine intervention in the post-meal window. That's important to recognize, right? Of course, there's hydrogen peroxide and free radicals and oxidative stress moieties in our body, but in the post-meal window, particularly a very high carb or high fat meal will lead to the overproduction of these particularly damaging free radical species. And that's exactly what you see here. But the thing that is important to recognize is after creatine, that is offset, which I think is important to understand. And you can see here is the blood flow is improved when we're comparing before and after creatine dosaging. And so I think that's important to consider, that there is improved blood flow within the skeletal muscle. Now, what I think is really important is the authors say that in this current study, the higher amounts of smooth muscle blood flow around the APO, and that's the way to measure the dialysis or the diameter, the amount of vessel expansion, compared to the control probe, was only observed following a high fat or high carb meal. So I think this is the application here. It's not like creatine acts like a vasodilator at rest. It may help with the improved blood flow in the post-meal window. So if you are, say, going to eat really fatty foods, for example, maybe you go to get I don't know, Kentucky Fried Chicken or Chick-fil-A on Saturday, right? Let's say, and you're going to have high-fat meals or really high-carb meals, have a pizza day. Perhaps preloading with creatine may offset some of the deleterious effects of the vasoconstriction that is normally associated with consuming those foods. So I think that's important. But I think it's also important just to recognize that, creatine is not sitting there enhancing, it's not working like nitric oxide enhancers such as arginine, citrulline, folate, B12, etc. But it may offset the post-meal induced constriction in your blood vessels. And they say that these findings hold clinical implications, particularly for individuals who's exactly what I was saying, whose dietary habits are typically characterized by frequent consumption of high carb or high fat meals, as it is known that these meals can lead to endothelial dysfunction acutely and over time. Okay, so now you might be wondering, well, how can creatine do all this important stuff in our circulatory system? The authors say a growing body of literature has begun to shed light on the potential of creatine monohydrate supplementation to lower reactive oxygen species concentrations and enhance blood flow. Lauer and colleagues demonstrated the potential antioxidant properties of creatine monohydrate as evidenced by its capacity to scavenge ionized radicals and in a controlled cellular environment, a finding that was replicated in both animal and human cell lines that had undergone oxidative damage. Similarly, in humans, creatine monohydrate supplementation resulted in a marked reduction in post-exercise oxidative stress as measured in the blood and urine. Notably, in the current study, hydrogen peroxide concentrations at any point in time, while not statistically significant, tended to be higher after creatine monohydrate supplementation. That's interesting. These results in findings could be due to stressor applied to stimulate reactive oxygen species concentrations from either exercise, high carb meals, or high fat meals. It is possible that the high fat or high carbohydrate meal used in the study did not elicit a robust or sustained enough increase in reactive oxygen species to detect a significant antioxidant effect. Compared to exercise-induced oxidative stress, the meal-induced reactive oxygen species response could be more modest or transient, and more pronounced or prolonged oxidative challenges may be required to fully reveal creatine monohydrate's antioxidant effects. Okay, now they go on and talk about other studies and so forth. This particular one by Asiero and colleagues found that creatine monohydrate combined with resistance training increased peripheral blood flow compared to just creatine monohydrate supplementation alone. Systemic arterial stiffness was attenuated following fatiguing isokinetic exercise in young men supplemented with creatine monohydrate. Furthermore, Morales and colleagues reported that creatine supplementation improved microvascular blood flow after post-occlusion reactive hyperemia. Indeed, in the current study, an external stressor such as a high-fat meal or high-carb meal may be needed to show improvements in blood flow with creatine monohydrate supplementation. Thus, the application of an external stimulus such as exercise, occlusion, or meal consumption might enhance the effect of creatine monohydrate supplementation on blood flow. However, following 3 weeks of creatine supplementation, individuals who chronically consumed a vegan diet exhibited a noted enhancement in baseline skin function, capillary density, as well as endothelium-dependent capillary recruitment. Now, why is this important? Because, as you know, if you're a vegan and you're not having any animal-sourced nutrition, you're getting no creatine. Like, you're not. Now, your body can make this nitrogenous amino acid-like compound that we know to be creatine through amino acids. It can be synthesized, but you're not getting any direct creatine. So that's important. Now, they go on to say that given that creatine is present in meat and fish sources, individuals adhering to a vegan or vegetarian diet possess markedly diminished creatine reserves compared to their omnivorous counterparts. Therefore, individuals who follow a vegetarian diet are likely to derive more pronounced benefits from creatine monohydrate supplementation. That's something we've talked a lot about. So for women and for vegan or plant-based individuals, you should definitely supplement with creatine, minimum of 2.5 to 5 grams per day. So in conclusion, it seems that taking creatine bolus doses for short periods of time may offset some of the meal-induced changes in blood flow, particularly the reductions in microcirculation that are accompanied by consuming high carb and high fat meals. I think that's important to recognize.